Chapter 4, Section 3 is writing functions, and we are writing functions to show the relationship here. Tammy charges $5 per hour for babysitting, so that would be y equals 5x. And these next ones, you always need to start with the change in the y. So from -2 to -1 to 0 to 1, we're going up each time. So y equals 1x. And then what you need to do is you need to pick any of these numbers and put it in here. And I'm going to pick the 4, so I'm not dealing with negatives. And if I put the 4, or put these numbers in there, so if the 1 is the y, and that becomes 1 times 4, so that would be 1 equals 4. Well, if we put 4 in place of the x, we want to get 1 back. But this time I got 4 back. So how do you get from 4 to 1? You have to subtract 3. So what we're going to do is we're going to subtract 3. And if we put the 4 in here, 1 times 4 is 4, minus 3 is 1. If we put the 3 in here, 1 times 3 is 3, minus 3 is 0. If we put the 2 in here, 2 times 1 is 2, minus 3 is -1. So your 2 steps here, you have to find the change in the y's, and then the second thing you need to do is test a point. And if that one didn't make sense, first one's always the worst, and you'll notice we have a couple of these to do. Number 3, look at the y's from 3 to 6 to 9 to 12. We've gone up 3 each time, so y equals 3x. And now test a point, and you can pick any one you want. Put this in for x. 3 times 1 is 3. Put this in for y. 3 times 2 is 6. Put this in for x. 3 times 3 is 9. So this one is good right now. Number 4, from 2 to 1 to 0 to -1, our y's are going down by 1. So y equals -x. And then we need to test the point. Let's put the 1 in here. So that would be y equals -1. Well, if we put 1 in there and we get -1, we actually want to get a 2 back. So how do we get from -1 to 2? And what we do is we add 3. So let's check these other points and see what we get. Putting 2 in here, you would have a -2 plus 3 is 1. Putting a 3 in here, -3 plus 3 is 0. Putting a 4 in here, -4 plus 3 is -1. So that one works okay. Number 5, from -9 to -7 to -5, we are going up by 2 each time. So y equals 2x. And then we need to put a point in there, or put the points in there, test it, and see what happens. I'm going to put the 0 in here just because I don't want to deal with negatives. So 2 times 0 is 0. I don't want to be at 0, I want to be at -5. So we need to subtract 5. And let's check these other ones. 2 times negative 1 is negative 2, minus 5 is 7. 2 times negative 2 is negative 4, minus 5 is negative 9. So those work. Number 6, from 4 to 6 to 8, we are increasing by 2 each time. And I don't want to deal with these negatives, so I'm going to test the point 0. 2 times 0 is 0, but I want to end up at 8, so we're going to do plus 8, and then you can test that. 2 times negative 1 is negative 2, plus 8 is 6. Number 7, from 5 to 7 to 9 to 11 is 2x. And let's test this point 0. If you put the 0 in here, you get 0 back. We put the 0 in here, we want to get 5 back. So 2x plus 5. And let's check. 2 times 1 is 2. Plus 5 is 7. 2 times 2 is 4, plus 5 is 9. And 2 times 3 is 6, plus 5 is 11. Number 8, from negative 4 to negative 1 to 2 to 5, you are increasing by 3 each time. And then I'm going to test 1, 2. 3 times 1 is 3, but we don't want it to be 3, we want it to be a 2, so you subtract 1. And I'm going to check this one. 3 times 2 is 6, minus 1 is 5. Number 9, looking at the y's, we increase by 2 each time. And if we put 0 in here, 2 times 0 is 0, but we want 1, so you'll have to add 1. And number 10, we are increasing by 10 each time. So y equals 10x. And then let's test a point. If we put 2 in here for x, we get 20, but we actually want 22, so we need to add 2. 11 through 15 are the same. We just add a second part where we are asked to find the 100th term. Looking at our y's, they go up by 2 each time. So y equals 2x. And if we put 1 in here, we get 2. 2 times 1 is 2. But we actually want 35. So we need to add 33 there. And to find the 100th term then, you would do 2 times 100 plus 33. And the 100th term would be 233. Number 12, we are going up by 7 each time. So y equals 7x. And if we put a 7 in here, or 7 times 1 is 7, we want to get a 1 back. So we will subtract 6. And to find the 100th term, 7 times 100 is 700, minus 6 is 694. So the 100th term would be 694. Number 13, Billy makes $8 an hour working at Subway. So that would be y equals 8x. And the 100th term, 8 times 100 would be 800. Number 14, -6 to -4 to 2 to 0 to 2 becomes y equals 2x. And I'm going to put this 4 in here. 2 times 4 is 8. But if we put the 4 in there, we want to get a 0. So 2x minus 8. And the 100th term then would be 2 times 100 minus 8, which is 192. So the 100th term would be 192. Number 15, let's see, from 18 to 26 to 34. We're going up by 8 each time. So y equals 8x. If I put the 1 in here, I would get 8 back, but I actually want 18 back. So we add 10. Let's just double check that. 2 times 8 is 16, plus 10 is 26. So to get the 100th term, we would put 100 in there, which would be 800, plus 10 would be 810. Function notation looks like this, and it's read f of x. And this is another way to write everything we've been doing. So rather than write y equals 2x plus 10, they're going to write f of x equals 2x plus 10. And you do the exact same thing, you just put the value in for x, and then you're going to get a value back. So f of x is 5x, and you want f of 6. You're going to do 5 times 6, which is 30. Number 17, f of -5, you are going to do 2.3 times -5 plus 10. And I think I got -1.5. And careful with your order of operations on this one. 1/2 -8 squared. You have to put parentheses around that -8 with your graphing calculator. So that becomes 32 minus 3, which is 29. Number 19, Mindy has already sold $20 worth of tickets for the school play. She has 4 tickets left to sell at $2.50 per ticket. Write a function rule to describe how much money Mindy can collect. So f of x equals, she already has $20, and then 250x, 250 per ticket. Reasonable domain, the numbers that we could put in here for x. Well, she only has 4 tickets left to sell, so it's possible that she sells 0, 1, 2, 3, or 4. And then our range, if she sells no more tickets, she would have $20. 1 ticket would be $22.50. 2 tickets, $25. 3 tickets is $27.50, and 4 tickets is $30. Bobby is ordering pizzas from DJ's. Pizza is $5.50 plus 75 cents per topping, and DJ's has 6 different toppings. So writing a function rule to describe how much money Bobby could spend, we would have f of x is 550 plus 75x. DJ's only has 6 toppings, so you could have 0, 1, 2, 3, 4, 5, or 6 toppings. If you don't add any toppings, your pizza would be $5.50. If you add 1 topping, it would be $6.25. 2 toppings would be $7. 3 toppings would be $7.75. 0, 1, 2, 3. 4 toppings would be $8.50. 5 toppings would be $9.25, and 6 toppings would be $10. So that would be your range. 21, tickets to Michigan's Adventure are $25 per person, and parking is $10 per car. Family of 5 is planning a day at Michigan Adventure. Your function rule is $10 per car plus $25 per person. There are 5 in the family. So I'm going to say 1, 2, 3, 4, 5 is your domain. And then your range, just 1 person goes, would be $35. 2 people would be $60. 3 would be $85. 4 would be $110. And 5 would be $135 for the range.